righty. Thank you. I'm going to give you a little update on what we're doing here with the museum. A year ago, I believe it or not, a year ago, 2019, when I spoke at TCCSA, I spoke on Marco Polo's discovery of a triped dinosaur in 1271 AD. He describes it in his travels journal during that time he was in China. With so much time with the COVID and lockup, I decided to build a 20-foot one. His was 50 feet long, and that was beyond my budget. So we built this one. It comes in a puzzle form, so I can break it down, take it in the car to camps and things. In fact, we were getting ready to go to a camp and had to cancel because of Amy had to have surgery in that, but she's doing well now. But anyway, that was great fun, and the kids really loved it, and they all dressed or used some of the weapons and things to kill the dragon. Then I'm going to back up here. My daughter-in-law, Kevin, my youngest son's wife, Melissa, helps businesses set up websites, and she's going to help me set up a website for just the Central Coast, California, so that people who are coming here, we have about 60,000 visitors a year from other parts of the state. Especially a lot come at Christmas time, because here we're still 70 degrees in the valley, Sacramento Valley. They go down to freezing sometimes during the winter. Anyway, this bone is part of a exhibit I'm putting together to bring in Boy Scouts, Boy Girl Scouts. They have one on archaeology with the merit badge program. Some of you may remember that from yesteryears. And with the merit badge program, the archaeology one, they're going to do an Egyptian archaeology dig, but I also plant dinosaur bones there. There's a reproduction of the tibia of a triceratops I dug 20 years ago in Wyoming. Anyway, then they dig this up. They have to put a plaster jacket on it, take it back to the museum, take it out of the jacket, clean it up, and then while we're digging it, they record it on a map, just like we did out the dinosaur dig for 18 years out in South Dakota. And then they get to keep the bone. So I'm advertising that. I'm also doing a Native American merit badge program too. And one of my homeschool moms is a scoutmaster, or whatever, mistress of a scout person, I guess is correct. And she's getting the word out. So thank you again for your prayers for Amy and me here out in California. And we're still hanging in there in spite of the virus and all those problems. So we're going to talk about the great Minnesota myth, glacier myth. These are pictures off of the website from Minnesota website about glaciers in Minnesota. So here's what they say: about 10,000 years ago, Minnesota was covered in glaciers about a mile tall. How it supposedly looked, and this is my creation. I superimposed Minneapolis here. You probably recognize it. Under a giant glacier. All right.
Russ?
Yes.
Sorry to interrupt, but you're not sharing your screen.
My screens aren't showing?
We're not seeing your PowerPoint.
Oh, wow. All right, let me get out here and see what I did wrong. Okay. All right, now I'll just show you the triped dragon I was talking about there, and there's one of the bones. It's almost 2 feet long, and that's what they'll get to dig and take home. And this is where we've used this 4 or 5 times with different groups coming to the museum. All right, back to Minnesota. Yeah, sure, you betcha. How it supposedly looked, and like I say, this is my superimposing of Minneapolis under the glacier. Now, this is another one that you see a lot of. Let me get this. Okay, there, now I'm better. See my screen better. Okay. Glaciers, this is again from their website. Glaciers began to form in the Arctic Sea due to a cooling world 20 to 50,000 years ago. The world continued to cool and more glaciers freeze at the poles, pushing ice outward. Eventually, they covered Minnesota. I will show you that scientifically, for glaciers to come all the way from the North Pole is scientifically impossible based on the crush to slush ratio that we see in glaciers. We'll show you that later on. All right, so the Great Minnesota Glacier Myth. When a parent asked for a place to show his kids evidence for glaciers, having been in Minnesota, the head of the DNR said, "There is no place." I'm going to give you the full quote at the end of this talk. All right, stay tuned for more evidence that shows glaciers do not crush, gouge, and bulldoze landforms. Every rock is a miniature history book of God's work on Earth, whether it is the size of a marble or boulders. In December, one of my Christian schools wants me to lead a group to the beach and show them the rocks and things there and how they fit into creation. And no matter which stone you pick up like these, or a nice big one like that, which we don't pick up, it has a history of how it formed, and we'll see some of that in this talk. Glacier theory is an attempt to explain geology by excluding the Genesis account of 6 days of creation and a worldwide flood. Most of you know this verse. I'm just going to quote the center here, 2 Peter 3:3-7. For this they willfully forget that by the word of God the heavens were of old, and the earth standing out of the water and in the water, by which the world that then existed perished, being flooded with water. The great glacier myth, glacier versus flood theory. So glacier theory, or GT, is slow processes over millions of years. Flood theory, FT, is fast processes over 1 plus a few days, years, 371 days until they got out of the ark. This is White Horse Mountain in Darrington, Washington. Many years ago, 2000, Trish and I hiked here in the summer, very beautiful there. And we got this far, see there at the bottom of the picture. We wanted to go clear up here to the main glacier, but it was a lot further than it looks. This is how it looks in winter. It's a beautiful, beautiful mountain there. Here I'm at the base of the glacier. You can see it in the background, covered with debris that blows off the trees, sand and mud that falls off the edges around it. There's many theories to account for the facts and data we see around us. This is the stream coming from the glacier here. Many geological structures can be better accounted for by flood theory than by the glacier theory. The term flood theory does not question the historical accuracy of the biblical flood event. Theory refers to how events not recorded in the Bible may have happened. In other words, the specifics of how certain gravel, rocks, and sediments were formed. Key to understanding the glaciers. I want you to memorize this, and then there'll be a quiz at the end, if we can. The question is always, where did the gravel come from? So remember that. If you remember that phrase, you'll get an A on the quiz. Now, on the tops of glaciers, as you can see here, this is another area, but there's present-day glaciers have gravel on their tops that are thought to leave clues to their activities of thousands of years, according to the evolutionary view. Crevasses catch gravel and rock and make deposits that are supposed to tell how glaciers have formed the topography. This is a crevasse on Mount Baker that's 100 feet deep, and my son Ryan was learning ice climbing, and he went out there for a week and a half take ice climbing classes on about the 8,000 foot level of Mount Baker. Here we are back at the Whitehorse Mountain Glacier. And again, the mountain is way up here, and this is summer, so there's not much heavy snow on there. What we want to see is that there's a whole different interpretation of the gravel and rocks based on a different worldview. Clues to gravel and rock formation and world history. Glaciers create sharp and broken rocks between mostly the freezing weather that freezes the rocks, the water inside, as you folks in Minnesota know, swells up and breaks the rock. Water makes rounded and smooth rocks. This is a geology book, Rocks and Minerals, that says this. It shows that glacier sand is sharp, while water sand is rounded. This is beach sand, but all of you are very aware of sand in creeks and rivers and that are rounded. They're not sharp and broken. Yet I've never been able to find a sample of glacier sand to compare. When I lived in Minnesota, I used to teach up at Duluth and homeschools at Elk River and Brainerd and all over. And every time I was out, I was always looking for samples to show the difference between glacier sand and rock and water rounded or flood formed rock. I only found a few samples. You'll see them in the video. Glacier theory depends on evidence provided by the gravel deposits they supposedly left. So here's Minneapolis. Here's the glacier ice on top of them that's supposed to be 1 to 2 miles deep, depending on what website you look at. And it covered Minnesota 10 to 50,000 years ago, as it said at the beginning, in evolutionary time. Note, there are no mountains higher than the glacier to provide gravel to fall on its top. That is a major, major problem in Minnesota glacier studies. Here we can see gravel could get on top of the glacier. This is a glacier in Alaska. Could roll down from on top there. And just as you saw on the Whitehorse Mountain Glacier, it had branches and dirt and junk all blowing down on it during the summer. And then of course that'll be buried by the snow that'll get up to 3 to 10 feet deep in the winter. This is an overview of glacier features that we'll cover in this talk. Kettle lakes, kames, ice blocks, outwash plain, terminal moraine, drumlins, and eskers, and we'll define those as we go along. All right, gravel drift. Gravel drift, the name given to debris carried by drifting icebergs during Noah's flood. This drift was then dropped on the earth as the icebergs melted. This was when scientists believed in the biblical account of a flood back in 17 and 1800s. So here's an iceberg with gravel in the ice, and the green represents the rocks that fall to the bottom to make gravel fields after the flood. Now, here's another glacier vocabulary word, till, but it's still gravel. I call it gravel till. That's a more modern name for it. Till, according to glacier theory, is sand, gravel, mud, and clay pushed up into a ridge at the end or snout of a glacier, or material deposited by a glacier as it melts and stuff on top of it falls down to the ground. There's the till. Gravel drift and till flood explanation. We agree that local small glaciers may leave this ridge today. However, the huge structures called moraines that are 50 miles long, 50 or more feet high, are made up of rounded rock and gravel from a flood, not till left from a glacier. And I'll show you the example over at Taylor's Falls. It's the main one in the Minnesota geological textbooks. The question we should always ask, tell your neighbor, if you're in the auditorium here, the question we should always ask, where did the gravel come from? And we'll look more about the gravel when we get to the moraines. All right, Kettle Lakes. I had a recent request about this. Kettle Lakes, glacier theory, shallow lakes which have been formed by glacial ice cubes, isolated and left behind by retreating glaciers. So you can see the main glacier here, the ice cube left part broke off as the glacier was retreating. Sand and gravel outwash from the glacier would flow around the ice cubes. When the ice melts, it leaves a kettle-shaped lake. So as the glacier leaves, gravel and that is flowing out from underneath and filling up around the ice cube. And when the glacier leaves and the ice cube melts, you've got a kettle lake. This is my dad near Mount Baker in Washington, 1950. We lived north of Seattle for 15 years in a town called Concrete. 1950, we had over 10 feet of snow. We had a 2-story house and we had to go upstairs to look out the windows because the snow had come up above the windows. So what's the problem with this theory? Here's what real snow does. And that's me up there sliding off our garage roof. The problem with this theory is, which this picture shows. Here I am, about 4 years old. This is my Tonka toy, made there in Minnesota, an earth mover. This is our woodshed. Over here is the barn and the chickens are out and loose. Now look at the globs of snow here, separated from the main mound, melt faster than this big pile here, 3 or 4 feet deep. Now that winter, this is in the spring, spring. My dad had to dig a tunnel from the porch over here where our house was out to the woodshed because we heated with wood. And so we literally had a tunnel through the snow. It was 10, 12 feet here, and especially when it blew and drifted. This ice cube would melt before it would form a lake from the gravel outwash because glaciers move very slowly, or I should say, when I say it recedes, it's not moving backwards, it's just melting. And supposedly the gravel flows out around this ice cube. But the main glacier, according to them, could be 1,000 feet thick at this point right here. The idea that it would leave this kettle lake, I believe, does not work when you run the examples here. How do we get these glacier lakes? This is Glacier Lake State Park. We went and visited that to look at one up front and personal. Here's my flood explanation. Present lakes formed between giant sand ripples made by the receding floodwaters. Here's an example in Washington State on a beach there, Lummi Island, that Trish and I visited in 1995. Every time the tide comes in here, it carves miniature hills and lakes in solid rock. The same thing would be true of the receding floodwaters carving the sediments left by the flood. The tide comes in every 12 hours here, of course. This is a close-up. Minnesota looks like this from an airplane at 30,000 feet. And Trish and I flying back to California one year, or out to Washington, I looked down from the airplane and it looked like this. The hills are covered with soil and grass, of course. Here would be the valleys. Here would be the Kettle Lakes. And as you all know, it's covered with 10,000 lakes carved by the receding floodwaters. Here the lakes are less than an inch deep and the hills about 2 inches high. But it provides an example of what water can do. And this is solid rock. And here I was, okay, I'm sorry, I got ahead of myself. One time when we flew to Seattle, Washington, I saw similar hills and valleys looking down in this area here. I told Tricia it looked just like the sand ridges we would see in the water at the beach, but these were 40 or 50 feet high. Here they can be seen in a few feet of water and are 2 to 3 inches high. They're even found fossilized. The troughs and ridges of the fossilized ripple marks in sandstone and siltstone are hardened versions of ripples in the loose sand of a modern day stream, lake, or sea. And I actually found some of these on one of my safaris, found a small rock about like this with these, they're called varves sometimes, fossilized ridges. And of course, when you go to the beach next time at any of the lakes, you can look down through the water and see the little ridges that the waves leave in the water. That comes to gravel kames. A gravel kame. Glacier theory says gravel collected in lakes on top of the glacier. When the glacier melted, a rounded, sometimes conical hill of stratified material, gravel, was deposited on the soil surface. So here's our glacier, the lake on top here. When it melts, the gravel and stuff that fell into the lake fell through and then makes a kame here. And that's how you know where the kame came from. Now, who remembers the question? Tell your neighbor so we know you're going to get an A at the end of the class. Where did the gravel come from? That is the main key to disproving the whole glacier myth. Here's a lake on a glacier in Iceland. I got this off the internet. I don't know how big it is, but anyway, they do form little lakes on the top. Now, where's that gravel they're talking about? That is the problem. Here's a kame complex in western Minnesota. There's one there, another one back there. If you drive from Minneapolis to Chicago, I used to be in the videotaping of horse shows, and several times as we drive along there, you can see the kames all the way along the highway there, all the way to Chicago in that area. Where did the gravel come from? Here's a professor's evolutionary explanation at Chippewa Moraine Ice Age Center Stark Park in Wisconsin. I was there at a camp, Christian camp, and we went to this park to show the kids what they claimed was materials left over from the glacier. And I was able to show them that it was left over from Noah's flood. I'll show you some more pictures of that in a little bit. Anyway, there was about 100 kids in this room, and the professor was explaining how the glaciers left the gravel and made all these things for Wisconsin and Minnesota. At the end, he asked for questions. So my hand went up and I said, I understand what you're saying. I'm trying to figure out if the glacier was a mile high, where would the gravel come from that would fall through when the glacier melted and formed the kame? And he said, kind of, pushed out his chest a little bit. Well, it's kind of like, you poor peons, you don't know much, do you? He says, this is what happened. The second glacier, there was a second glacier with gravel in its foot. It pushed up over the first glacier, depositing gravel in the lake. And this was another glacier coming from further east of Wisconsin, pushing up on this already mile-high glacier. And the gravel trapped in its foot underneath here fell off into the lake. And then, of course, when this glacier melted, that would leave the came down here. Reasons this will not work. I was going to raise my hand again and bring up a few more ideas. But there's 100 kids waiting to get out of there to have lunch or get back to camp. And so I thought, well, I'll wait at the back door, back of the room and ask him my second question. And I waited and waited, and he had ducked out the back door, and I never saw him again. First of all, heat from the contact plane would melt the glaciers just as when you rub your hands together. And that would probably ruin any gravel that was stayed there. I mean, it would get dropped long before it got on top. Now, if you read Dr. Walter Brown's book, and I just lost the name of it, but I'm pretty sure Byron may have it in the bookstore there. But he's written extensively about the idea that mountains, younger mountains pushed up over, older mountains were pushed up over younger mountains because the fossils in some mountains on top of higher up, the fossils are older than the strata underneath them. And he shows mathematically in the back of his book that that's impossible. There is no force strong enough to do that for a solid rock, and neither is there a force strong enough to push a glacier up on top of another glacier. Third is the crush to slush ratio, which later we're going to show you when we talk about Iceman. And he'll set the record straight. We'll get back to him in a little while. So I never did get talk to that professor. I would like to ask him what would push the ice up on top of a mile-high glacier. Now, gravel eskers. Glacier theory says that long, narrow, and often branching ridges of poorly sorted gravel and sand. The glacier theory says that they were formed by gravel that was deposited by streams that flowed inside the glacier. So picture a tunnel inside of the glacier here and a stream running through it. And as the stream runs through it, it deposits gravel in the bottom, similar to the Kettle Lake theory up here where there's a lake with gravel in it. And then when it melts, it leaves an esker. What's the question? Everybody should know it now. Where did the gravel come from? That's going to be the main question on the pop quiz. All right, here is the supposed esker over here, like a long snaky-like thing. An esker would not be formed here because this is at the bottom of the glacier. They claim that the esker, as here, had to be somewhere up in the middle of the glacier. Also, here, this stream creates a V-shaped bottom or riverbed in the soil beneath it. The tunnel has to be higher up in the body of the glacier as seen here. Now, this is Ripley Esker by Camp Ripley in Minnesota. I used to teach there and or north of there in another town. And Sunday I would leave about 4 in the afternoon, drive my van up, sleep in it, and then explore the esker get up at 6. I had to teach class at 10. And I would explore the esker. And I ended up over a period of 5 or 6 years exploring the whole 7 or 8 miles length of it. This is it in the background there, covered with trees. And it's about 50 feet high and about 7 miles long. This is like the one, I couldn't find a high picture of the Ripley one, but this is very similar to it. And you can see how it kind of wanders through the landscape. Here we took an adventure safari on it in 1995. We're almost to the top there. Problems with the glacier theory. Here's the downhill slope and how a normal branching creek looks and works. The water flows downhill and cuts a V-shaped little valley or creek. Gravel esker glacier theory explanation. Based on their supposed downhill direction, gravel eskers often branch uphill. Here's the assumed flow of the river in the glacier or creek, but some of the branches are actually going the opposite direction. And I saw some of these on the Ripley esker. They were coming in at the wrong direction. And so creeks flow downhill, but here, this is the downhill here. So the creek should be coming in this way if it was flowing correctly in the glacier. This means that if it was formed as a stream in a glacier, water would have to flow uphill. Here, flowing uphill. This is the uphill side. Flood theory explanation. Ocean currents meeting and carrying gravel in opposite directions could make the esker, where the water slows down because of opposing currents, the gravel drops out to make the esker. What question does the glacier theory not answer? Where did the gravel come from? When I first came to Minnesota, I asked about any mountains. I was from Washington State, lived under the eyebrow of Mount Baker, which was 10,000 feet high, and Mount Sauk, which I saw every day when I walked to school, which is about 5,000 feet high. I was told that about Eagle Mountain, the highest place in Minnesota. I said, wow, that's cool. Maybe we'll go, I told Tricia, maybe we'll go there and hike up the mountain. I said, how high is it? And they said, it's about 900 feet. I'm sorry, but I laughed and I says, wow, in Washington, something that small, we just call a foothill. We don't even have a name for it. Don't want to insult Minnesotans. I did live there for 32 years, so and people still meet me here saying, well, you have a Midwest accent, even after 16 years here. We all know there are no mile-high mountains in Minnesota. There are no mountains higher than the glacier to provide the gravel. And to me, this is one of the biggest reasons why glaciers in Minnesota, that theory doesn't hold water or ice. They need to be a mile high at least. Now the Rockies are 2.75 miles roughly. And so if there was a glacier there, yeah, gravel would roll down on it and be on the top, just as we saw with that glacier in Alaska. The flood theory says that the gravel was carried by the floodwaters from some other location and dropped here where the esker was formed. At the Ripley esker, I talked to one of the excavators because this is right off the road and they were They mine the gravel and screen it to get big rocks, middle-sized rocks, sand, etc. And I asked him if the gravel was connected to the subsoil. The esker was here, and there was no strata break between the esker gravel down here. This all means that the esker was made by water movement depositing the subsoil gravel and the esker gravel at the same time, not by gravel dropping out of a glacial tunnel. There's an esker up at Now Then called the Greenberg Esker. We took a group up there one time and followed it from a farm way over here to the west, and it goes back this way about a mile or 2 miles to another farm. It's just off the road there by the Greenberg farm. There you can see some of the hump, and they are mining over here. They've mined the gravel out of it. We also see esker-like structures in wind-blown sand. This is part of the Gobi Desert in China and covers 130,000 square miles. It's called Takla Makan, which translates, you go in, you not come out. It's a very, very hostile place and covers so much square miles, very little water, and you don't really want to go in there. What this all means is scientists are working with the wrong assumptions. What would research show if we assumed the eskers were made by floodwaters? They are asking the wrong questions. They're asking about how glaciers make eskers. We need new questions. We should be asking, is there any other way eskers could be made, like by wind or water? And I've shown my water explanation. Erratics. This is a giant rock on the way to my house where I used to live when I was, that picture where I was 4 years old. It's a huge rock. There's nothing else around it. And my brother and I used to think it was blowing out of Mount Baker and landed here when it blew up. The present theory is that a glacier left it here. We'll show you how that doesn't work. Erratic rocks. Glacier theory, rocks that have been transported by glaciers from some other location. They were either transported in the foot or bottom here, or rolled down and fell on top and were transported. And then when the glacier melted, it was left on the edge of a mountain or something. An erratic in the Adirondack Mountains of New York had been supposedly transported 600 miles from the north and uplifted. That means it was 2,700 feet above sea level. And note that it's a nicely rounded rock. That means it had to be formed by water movement. Glaciers don't make rounded objects. What's the question? How did it get on top of a mile-high glacier? There's no high mountains 600 miles north of New York. High-speed water moves huge rocks. This is a picture from The Genesis Flood by Morrison Whitcomb, which is one of my life-changing books. I saw it at the University of Multnomah Seminary Bible College in 1965 when I graduated from high school and went there for college. And I used to take it off the bookshelf and read pages of it, and I thought, man, this is incredible. I scraped enough money together to buy it. And as I read it, I thought, and this was really my first contact with what I call creation science. And when I read it, I thought, wow, science supports what the Bible says about the flood. And it was what I call a life-changing book. We had a conference at, I'm forgetting the names of the towns. Anyway, where Mayo Clinic is, we had a conference there. And some of you will remember the man that used to set them up. And Morris and Whitcomb both came for a conference there, and I had them sign my book. So that was a nice event. Now, the flood explanation is that ocean currents traveling at 50 miles per hour can carry rocks as big as a house. There's a person standing there in front of it. And these were washed down from up here in the mountains. Now, this is a quote from Bob Helfenstein, my friend and mentor, and many of you remember him. George Macready Price wrote the formula on water transport of materials. The transporting power of water expressed in terms of water velocity, T equals V6, a 10 to 1 increase in velocity will produce an increase in transporting power of 1 million to 1. And I appreciate Bob Helfenstein. He was a great mentor, man of God, and great inspiration. Helped me on writing my book, Design versus Chaos. And now his son, Alan Helfenstein, maybe you're there today, Alan, has helped re-edit it into scientific format. And we've got it on Amazon.com. And we have made maybe $4 or $5 selling books there, but at least it's out there. And I'm very thankful for Bob Helfenstein and all his help over the years. In this, a current of 2 miles per hour will sweep along pebbles the size of an egg over a relatively smooth surface at 2 miles an hour. Here comes our egg bouncing along, a rock egg. Now, a current of 20 miles an hour will move blocks weighing 320 tons or 640,000 pounds. That's using that formula that Bob Helfenstein gave me. 20 miles per hour, and we've got a major chunk of rock. Now, I didn't show it here, but the water would be much deeper. It would have to be 30 or 40 feet deep. The tsunami of 2011 that came from Japan was moving at 600 miles per hour. These are pictures of the tsunami as it's coming into the bay there and washing over. And here, of course, it's hitting here. At that speed, it could carry a rock the size of 2 or 3 school buses. It hit our town in California 12 hours after leaving Japan. Kind of a strange thing happened 2 days ago. My brother Mike, who lives in Washington, sent me a video that claimed to show that China had released tremendous amounts of water from some of their dams because of the high flooding. And this was a picture of that water, and it was rolling along here and throwing these cars in, and boats were falling in. And as I watched it, I thought, I've seen that picture before. And I had just found it for this program that I'm teaching tonight. And this is not in China, it's in Japan. And it was recorded in 2011. So I wrote him and said, whoever sent you that used the wrong material. I've been tracking some of the things in China that are happening because Amy, my new wife, is Chinese, and we're interested. We were going to go there as missionaries, and things have all shut down. First, we were going to go to southern China, then to Hong Kong, and then to Taiwan. The day we were going to get on the airplane to go to Taiwan, everything shut down, and we took a taxi and went home. And so we're waiting to see if God opens those doors. Just an aside, one of my parents, Faith Bauckham, was raised in Hong Kong. Her parents were missionaries for 30 years there. When Hong Kong was absorbed into China, they moved into the southern province of Yunnan province, and they had to leave in 2020 because of the virus. And the Chinese government is coming down more and more on Christian groups. And her parents are starting a camp north of Spokane, Washington, in a little town called Colville, to try to bring Chinese college students from the different colleges there in Spokane, Seattle, Bellingham, and to evangelize them and teach them about Christ, and they've invited us to come and teach our materials there. So we're hoping that might open up for this summer. All right, striated rocks. That's where there's big scratches in rocks. Gravel, glacier theory says that gravel caught in the base of the glacier, ice, acts as sandpaper as it is dragged over the underlying rock. This creates striations or scratches in the bedrock underneath the glacier. Striated by glaciers or water. Notice here these striations are going different directions, which they don't explain how that happens. Now, the geology textbook said that at Taylor's Falls, Minnesota, there were striations in the rocks that showed where a glacier came through. I'm going to plow and gouge this baby down. That's the glacier coming through. I asked the ranger where we could look at the striations. The park ranger told us, but said there was another explanation for the striated rocks in the park. She said water moving at high speeds carrying sand and gravel could have caused striations on the basalt rocks in the park. These are some of the striations here. This is a really old camera picture, and so it's not too good. I knew there was another interpretation, but had never expected a non-creationist ranger to admit it to us. I almost lost my balance. I personally thought these scratches that covered only an area of 10 by 20 feet were too small to be even accounted for by water, let alone a giant glacier. But that was their explanation. Gravel outwash plain. Glacier theory says the rocks that are washed out from the glacier should be broken and cracked. A lot of the broken rock is from frost breakage that we see here, and all of you in Minnesota. Here in California, they don't know too much about really cold weather. But, and people will ask me, they'll say, well, how do you like the weather here? And I say, every day without snow is a perfect day. And I just can't do snow anymore. But anyway, there's some cracked rocks here, but there are some that are broken off from frost and fallen down here. And there's a few sharp rocks. The flood explanation, the outwash plains almost always have water, rounded rocks, and sand. As I say, I've been searching, I searched Minnesota in a lot of places for examples of broken rock and sharp sand, and never did find the sharp sand. I know because I used to plow it with my father-in-law in the 70s. This is out by Anoka, and we rented 800 acres of land to plant corn and soybeans. And here I'm almost stuck in the mud. But this is, they called it Elk River sand, I believe. And the sand was everywhere. If we plowed up a rock, we'd get out to look and wonder where it came from. There was never any rocks or gravel here. It was, always 4 to 5 feet deep of sand. There's a park near where we used to live to the south here, and it originally was all sand dunes. And back in the 20s and 30s, they planted evergreen trees in there to help hold the ground from blowing away. This is Anoka County here. Here's Andover, where we used to live. And this is the outwash plain, which is all sand and is claimed to have been outwashed from the glaciers that were here thousands of years ago. Covers 250 square miles. As an eyewitness, having farmed it for many years, I say it's leftover from Noah's Ark, Noah's flood. Like I say, there's no rock in it. It's all sand. We farmed here. We farmed and had been up to Bethel because we would go and fill silos with people. We were over in this area here. But I've been up to these areas for different schools and things and looked at the sand and looked at the geology books. And that's a big problem to explain why there's no rocks and why there's no sharp sand. Here's St. Cloud, where I used to teach, and the esker is somewhere on the way there. Can't remember where, or no, it's beyond St. Cloud. I'm sorry, it's way up here to the north. All right, we're almost done. Basal sliding, or how the base slides. This is another picture of the Mount Baker Glacier where Tricia and I hiked many years ago. Basal sliding gravel, the action of the glacier where it slides against the underlying rock. Headline, glaciers move on a cushion of water and therefore do not cut, gouge, and bulldoze. And this was in a Discovery magazine article many years ago. So this idea that it's cutting and gouging here and making striations has been falsified, because they found now that the glaciers ride on a cushion of water, like these boats that you see that are pushing, they float on the water, and then they have fans that push them up and they float across the water. By the way, there's over 150,000 glaciers in the world. Only about 75 of them have actually been explored and analyzed in that, contrary to Mr. Al Gore, who showed 12, I believe it was, in his movie, An Inconvenient Truth. The ones he showed are the ones that are getting smaller. But there's one in Alaska right now that's growing by 6 to 10 feet a year, in surges it's called. And there's glaciers all over the world that are actually getting bigger, including the ones at the South Pole. And that's a whole nother program I could do someday. Thus, if there's gravel on the base, it will not create striations. Now, plucking, and we're going to get to the Iceman in a minute. This is a geology textbook picture. Ice freezes to the rocks, and as the glacier moves ahead, it pulls the rock out of the ground, crushing it and carrying it to the bottom of the glacier. So here it is, it's pulled out, and then it's pulled down here and deposited down here. The dead man refutes glacier plucking theory. Have I got a story for you? The Iceman discovered in the Alps, Austria, 1991. They put his time living at 3300 BC evolutionary time. The Iceman's body appeared to be younger than his actual age. This means he may have lived shortly after the flood, when people still lived to be 150 to 250 years old. He might have been a great-great-grandson of Noah, out exploring the new world after the flood. I put his date at about 2100 BC based on a biblical timeline. These are pictures from an article. About 5,300 years ago, the Iceman died in a narrow hollow in the mountains. Most likely a cold, dry snow began to fall shortly afterwards, freeze drying the body. So first he died and was covered with snow. Over hundreds of years, more and more snow fell. Eventually, a glacier moved over the rocks, but the Iceman's frozen body remained protected in the hollow underneath. I emphasize that because what about plucking? Slowly the glacier began to melt in 1991. Desert storms in Africa blew dust clouds that caused it to melt. Now they'll find me. In September 91, Erica and Helmut Simon spotted the Iceman's head in the melting snow. Scientists believe the body had been uncovered for about 3 days before the discovery. The discovery of the Iceman casts doubt on the glacier theory that says plucking pulls rocks out of the ground. He was never plucked out for 4,000 years or thereabouts. It is said that the Lake Superior was formed by glaciers going across and plucking the rocks out down to 1,500 feet to make a hole in the ground for the lake. By the way, they call this the Great Superior Glove To me, it looks like a dragon. There's his eyes, there's his mouth, but I always think about dragons and dinosaurs. I believe the lakes can better be accounted for by Noah's flood washing across and digging out a hole that later was filled with water. This would be done by cavitation, which is the explosion of collapsing oxygen molecules. And that is also an explanation of how the Grand Canyons could be formed very quickly in just a few days with huge amounts of water rushing through. Cavitation we often see on the propellers of outboard motors. And my dad used to repair these when we had a marina. Cavitation is, as it says here, oxygen exploding or collapsing, which makes little holes in the propeller. Some of you may have seen that on your fishing motors. The theory says that glaciers crush and bulldoze. Here, crushing did not occur on this man who was under the glacier for 4,000 years. Why wasn't he crushed? The theory says that glaciers pick up and transport materials in their base long distances. Here, transport did not take place. He says, I should have been plucked out and smushed all the way down the mountain. Let's look at how glaciers in the real world work. Here's the crush to slush ratio. And this is the Mount Baker Railroad grade, which I've investigated with Tricia many years ago. And even when I was about 19 or 20, my best friend and I hiked up there and looked at it. All right, glacier movement. Height to length ratio. The higher the glacier, the more the top flows up here. The lower the glacier on a downhill slope, the more the base moves. Antarctic glaciers are 2 miles thick and the base does not move. And this is from a Time Life book on glaciers. The base is stationary, it's too heavy. And so the top, the ice crystals flow like water along the top, only very slowly, maybe 30 feet per year. Just the top is moving 30 feet per year. Movement stops when the glacier hits higher ground. Glaciers follow the same laws as moving water. Rivers do not flow uphill, and glaciers do not flow uphill. When the distance is over 7 miles on level ground, the friction in the foot is greater than the ice can withstand, and the ice crushes and pushes upward rather than push forward. I call this the crush to slush zone. And so you get pressure ridges here, similar to those kind found in the Arctic Circle, where the ice is pushed up, and this happens after it reaches 7 miles long. Glacier theory says that this part is moved forward by pressure from the head of the glacier. When it is over 7 miles long, it stops moving. The glaciers that supposedly came from Newfoundland and crushed, bulldozed, and gouged Wisconsin, Minnesota, that's 600 miles away. And Minnesota is 800 feet above sea level, and the glaciers came from zero. So they had to go uphill all the way to Minnesota. Now, these are, let me go back, till, gravel, and terminal moraines. Glacier theory, broken sand, gravel, mud, and clay is pushed up into a ridge at the end or snout of a glacier. Geology textbooks say that this gravel or till is always broken and cracked. What does the data tell us? Do we find broken gravel till in moraines? This is Kettle Moraine State Park in Wisconsin, where I went and heard that lecture I told you about earlier. And it's supposed to be broken gravel till. What's the question? Where's the sharp glacial rocks? Practically all of these rocks, and there's a whole mound of it, a couple of miles long. We walked some of it, and it's practically everything is rounded here. Find a few rocks that are cracked from frost. According to geology textbooks, a terminal moraine is made up of unsorted, broken, and cracked rock with a paste-like muck in between. Here and in the next picture, we have rounded material with fine water-rounded sand in between. Here's a pile of rock next to the exhibit center. Yeah, I couldn't find any. Well, maybe that's a sharp broken rock, but the rest are all rounded. And again, they cleaned this out of the parking lot and claim it's left over from the glacier. What's the question? Where are the sharp broken rocks? Here's an erratic, the one on the right, carried here by glaciers or floodwaters. The plaque near it says this came from a granite outcrop 60 miles north. The problem is that there is no glacier no other evidence of a glacier, as you saw in the previous slides. We say it was transported here by floodwaters. Gravel terminal moraine at Taylor's Falls behind the motels. If you ever get out there, take a look. I think when I was there 7 or 8 years ago, we did go out and visit the moraine for a geology hunt. Even if I'm a little erratic, I can tell a round rock from a sharp one. Here's a close-up, and I did take samples of the sand home and looked under a microscope at them, and they were all rounded. And there's some rounded rocks here. There was others, let me back up, down here at the bottom, all huge rounded rocks. Do the rocks show evidence of a glacier or flood? The field data shows water-rounded materials every time. The rocks win. The rounded rocks win. Gravel moraines cover these areas in northern Minnesota. There's Duluth and Mille Lacs Lake, and these can again be accounted by currents flowing in different directions. I'm sorry I didn't get to the these long, well, some of these are eskers, not eskers. The smaller moraines. Here is Sharp Edge Rock above Taylor's Falls, and that's Rex, my dog. He said, this is a typical glacier rock. I said, no, this is frost breakage. Just over on this side is a huge cliff that the rock freezes and falls off of. Water rounding. Here's a water rounded boulder near Santa Paula, California. Here's another one. And in order to form this, you had to have a flood 20, 30, or 40 feet deep running for many months to grind these rocks into a nearly round boulder. Atlas, look out. Well, I had to try. Find the glacier rocks. Here's a pile in South Dakota. All through South Dakota, there's these piles of rocks. We couldn't find any broken rocks there. Another pile in Stockholm, South Dakota. Again, one rock I found that was sharp, and that again could be accounted for by frost breakage. These are all rock piles that the farmers take out of their fields. I used to stop at them all over Minnesota. And then when we went to North South Dakota, I would stop there and look for evidence of a glacier. Couldn't find it. I did find Noah's Ark's anchor. This was at Millbank, South Dakota. If you get down there, look it up. Right here, it says this is the anchor from Noah's Ark. Founding Fathers and our conclusion. In 1962, Morris and Whitcomb said in their book, The Genesis Flood, the one I told you at the beginning, that all geological formations attributed to glaciers could be explained by the activity of a worldwide flood. One of my parents decided to see for himself about glaciers in Minnesota. He called the head Minnesota DNR and asked where could he take his kids to show them evidence for glaciers in Minnesota. There was a pause. He said, hold on, I'll ask someone. The man talked to someone else in the room. He came back on the phone and said, there's no place to show evidence of glaciers in Minnesota. This is Mille Lacs Lake and just the snow piling up on it there. People have been taught for 100 years that Minnesota was crushed, gouged, and bulldozed by glaciers. Yet there is no scientific evidence. Rule of thumb, dude, the clues are in the rounded gravel and rocks. Look for that. Conclusion, no evidence for a glacier in Minnesota. 2, much evidence for a catastrophic flood. 3, best explanation is Noah's flood, a worldwide flood. Each geological feature is a witness to Noah's flood. God's mercy always provides a way of escape from his judgment. And Hosea 6 says, I desire mercy and not sacrifice, and the knowledge of God more than burnt offerings. Ezekiel 33:11, say to them, as I live, says the Lord God, I have no pleasure in the death of the wicked, but that the wicked turn from his way and live. Turn from your evil ways. The purpose of the ark, and this is our last picture, the ark was a giant billboard to warn people of his coming judgment. He could not let the world go on in sin and rebellion, Isaiah 2:5-22. Thirdly, it shows God's mercy in that God always provides a way of escape from his judgment, and that's Ezekiel 33:11. Before the flood, the earth had a problem, and that was sin, of course. God brought judgment, which was the flood. He had Noah and his sons, who were the witnesses and the evangelists who went out for 120 years to tell people to repent, tell them of the coming judgment. God always in his judgment provides mercy, and the result was salvation. Today, God is going to bring judgment again. We still have the problem of sin, and Revelation says it'll be fire. Who is going to warn the people of this coming judgment? It's going to be Christians. And of course, in God's mercy, he sent Jesus to die for our sins. And if we accept him, we have salvation from that coming judgment. And that brings us to the end. You can get our email if you have more questions, or email. And that brings us to the end.
Well, you mentioned that the glaciers are currently growing in some areas. Is there a reason for that? And that goes, of course, counter to all the hype about global warming.
Yes, that's correct. I found a website, and I'd have to look it up, but if you just Google on growing glaciers, it might come up. And this was about 7 or 8 years that I found a whole list of them. And the reason they're growing is because our climate is pretty stable. They have satellites up, weather satellites, that when I did my program on global warming, which I think you can check with Ross, we did that 10 or 12 years ago, I think, and it might be in the archive somewhere. I found that with these satellites high up in the atmosphere, the variation in temperature over the last 50 years is less than 1 degree. And being from Minnesota, when I first heard about global warming, or in this case, I thought, wow, they must mean it's going to get 10, 20, or 30 degrees hotter, and they're saying that global warming right now is only like 1 or 0.5 degrees, which is just a little bit of a swing over thousands of years. There's a book in the library called The 1500-Year Cycle, and he shows, based on the last 3 cycles of 1500 years, that there'll be a little upgrade of 1 or 2 degrees and a little downgrade of 1 or 2 degrees over that 1500-year period. And that's an excellent book to get. Again, if you need more information, get my email and email it to me, and I'll give you the references and things like that. And so it's just normal. Al Gore showed one part of the South Pole. If you remember, when you look at the South Pole, you'll see this big arm that goes out from it on the northern side. And he showed in his movie the ice that was in that bay there, which covers 100 miles or so, broke up and flowed away. And he says, see, this proves global warming. It got too warm and it flowed away. I found out 6 months later, or maybe it was a year, that that whole bay is refrozen again. Yeah, it was a little warmer for 1 or 2 summers, and then it was back to normal where it all froze up again. But again, the drive-by media and Mr. Gore do not go back and correct the mistakes they made. He used Mount Kilimanjaro in Texas as his poster child or poster picture of glaciers melting. And he showed 1950 what it looked like, and then 2000 what it looked like. And yeah, it had receded quite a lot, way up to the top. I looked up again information, and the scientists said it's not due to global warming. It's due to the fact that all around Mount Kilimanjaro, people have cut down the trees. The poor people cut trees to burn to cook their food or make money by selling the logs. And so now the hot desert wind is coming off the desert there, and it's melting the glacier. It has nothing to do with global warming. It has to do with cutting all the trees down. I can take another question.
Try that one. Try that.
Okay, a question.
Yeah.
How do we explain the driftless area in Minnesota?
How do we explain the
Driftless.
driftless area? The driftless area in Minnesota, can you hear? Can you hear the question?
I think so.
I think so. There's no drift in southeastern Minnesota.
Okay, yes. All right. Southeastern Minnesota, and my son Ryan's wife is from that area, and her father farms there. And we who farmed in Anoka County were always jealous of southern Minnesota because they had, in some places, 10 to 20 feet of beautiful loam soil, and all we had was sand. But they could grow tremendous crops down there. And the area there, I would explain it being that that particular area, the ocean currents, when they're retreating after the peak of the flood at 150 days, then as the waters receded, they would drop down, the loam would float on top more than the rocks. And so as they retreated, they left more rocks and sand in Northern California, northern Minnesota. And then as the waters subsided and retreated towards the Gulf of Mexico and slowed down, it would drop out this loam or good farming soil. That would be my idea on that.
Yes.
Just a comment. I saw Russ probably 7 or 8 years ago at a homeschool conference over in Brooklyn Park. And having seen this the second time, it's a lot more sense than the first time. There's so much information.
Okay, someone who saw this presentation 6, 7 years ago, 7 or 8 years ago in Brooklyn Center says that Brooklyn Park. And it's easier to understand hearing it the second time.
Oh, okay. Well, thank you. I appreciate that.
Okay. Any more questions? Question? Okay, well, thank you very much, Russ. This is very, very revolutionary for Minnesotans. We have not always been covered by eyes.
Yeah, well, thank you for having me. And we hope we can come out in next September, Lord willing, if the virus don't rise and we don't get any more floodwaters or anything else. So we're looking forward to coming eventually to Minnesota. So you guys take care, and we'll look forward to that. Thanks so much for having me.